A cubic equation with a real coefficient has at least one real root. This is the first question. So, is this true or false? This statement is true because consider a cubic equation ax cube plus bx square plus cx plus d is equal to 0. In this equation, if a complex root occurs, it will be in conjugate pair, that is a plus ib and a minus ib form. In a cubic equation, there will be three roots. If two roots are complex, then one will be real. If there is no complex root, if there is no complex root, then all roots will be real. So the next question is, if A and B are two sets, then A union B is equal to B union A complement of B. We want to prove this statement is true or false. So firstly, write this. If we want to prove A union B is equal to B union A complement of B is true or false. So firstly, we want to prove left LHS is equal to RHS. So first we consider, let x is equal to element of A. Let x is equal to element of A and x is not element of B. Then y is equal to element of B and y is equal to not element of A. Then from this we can see that xy will be element of A union B, that is xy will be element of A union B. So if we can prove that xy is element of A B union A complement of B, then these will be equal to A union B. So hence we can prove this. So if we check B union A complement of A, y will be element of B and x is element of A complement of A, because x is element of A and x is not element of B. Hence xy is element of B union a complement of A. So LHS is equal to RHS. Hence, this statement is true. So, if we look at the next question, the curve y into x square plus 1 is equal to 3 has an oblique asymptote. So, from this, we want to check. This question number is 1 of 3. So, we will consider the third question. That is y into x square plus 1 has an oblique asymptote is the statement. We want to check that if this statement is true or false. If we consider, we can rewrite this equation as y is equal to 3 by x square plus 1. We know that if a equation has to be oblique asymptote, its numerator's degree should be greater than denominator. Here, numerator's degree is equal to 0, a constant. But the denominator's degree equal to 2, which is greater than numerator. So hence the equation is not an oblique asymptote. So the statement is false. So the next question is, the greatest integer function is continuous on R. We want to prove that if this statement is true or false. From this we can see that this statement is false. Let me prove that. So the question is 4. So statement is the greatest integer function is continuous on R. We want to prove that if this statement is true or false. Let box x is a greatest integer function. So if then 1 will be then box x is equal to 1 will be the value for x, the value for then 1 will be the value for whenever x is greater than 1 and less than or equal to 2. Greater than 1 and less than or equal to 2. And 2 will be the value of x when x is greater than or equal to 2 and less than 3. So from this we can see that the graph will be like this, like this, like this, like this. From this we can see that the function is not continuous from this graph. So the statement is true. From the graph we can see that the function, we can see that the function is not continuous and the statement is false. So next question. Critical point, next question, fifth question. A critical point of a function is its extreme point. This statement is also false because a extremum point of a function will be its critical point, but it's not necessary to be a critical point to be a extremum point. We can prove that. So fifth, we can prove that let f of x equal to x cube, then f dash x is equal to 3x square. By taking the derivative, it will be 3x square. That is n into x raised to n minus 1 by this formula. So when we put f of 0, then 3 into x square 0 is equal to 0. So from this f of 0 is equal to not 0 is not greater than 0 or less than 0. So from this we cannot see this is a extremum point or minimum point. So the critical in this function, the critical point is not its extremum point. So the statement is false. So the sixth question is the maximum possible domain of a function f given by f of s is equal to root of 1 minus x by x is 0 and 1. Is 0 is not included and 1 is also not included in that domain. So first of all, this is sixth question. Sixth question. Domain means the value of x and range means the all possible value of f of x. Here the given statement is f of s is equal to root of 1 minus x by x as range 0 and 1 excluded. This statement is false because first, but when we look at that we feel like this statement is true, but it is false. Let me prove that. F of x is equal to root of 1 minus x by x So has domain 0, 1 is false because so root of 1 minus x by x has to be domain. Two conditions must be satisfied, that are the value inside the root, that is one, this value should be positive. 1 minus x by two conditions. 1 minus x by x is greater than or equal to, should be positive, and denominator x should not be 0. Denominator should not be 0. By these two conditions, both the denominators must be same sign, that is both must be positive or negative. So from that, let's consider case 1. Case 1, both positive or 0. So 1 minus x must be greater than or equal to 0. So 1 is greater than or equal to x. So by the denominator's rule, x cannot be equal to 0. So x by denominator's rule, x cannot be 0. So the value should be between, the value of x should be between greater than 0 and less than or equal to 1. From this, we have already proven this is false. But we let continue further. By second conditions, both are negative. Both are negative or 0. By this, 1 minus x is less than or equal to 0, and x, from that x will be greater than or equal to 1. But both the denominators and the numerator should be same. X must be negative, that is less than, x must be less than 0 by these conditions. But both the conditions cannot be simultaneously true. The conditions can be simultaneously true. Hence this can be included. This can be included, but by case 1 x can be 0 greater than 0 less than or equal to 1. So the range will be 0 excluded and 1 included, because 1 minus 1 by 1 I would say 1 minus 1 by 1 root of is equal to root of 0 by 1 is equal to root of 0 is equal to 0, which can be in that possible range, but denominator cannot be 0, so 0 cannot be included. Hence the given statement is false. The next question is d by dx of sine x square is equal to d by dx of sine square x. We want to check whether this statement is true or false. For that we can use the chain rule. By applying the chain rule, first we write the statement. Seventh question. D by dx of sine x square is equal to d by dx of sine square x. We can check the LHS of the equation, value of equation. If LHS is equal to right hand side, then the statement is true. If it is not equal, then the statement is false. So by chain rule, d by dx of f of g of x is equal to f prime g of x into g prime x, that is d by dx of sine x square is equal to derivative of f, that is derivative of sine, that equals cos into x square into derivative of g of x, that is derivative of x square, that is 2x. It will be 2x into cos x square. It is the final value of the derivative of d of sine x square. Then the derivative of d of x sine square x, we can rewrite it as d of sine x into whole raised to square. From this we can consider the inner function u as sine x, that is u is equal to sine x. The outer function f of u is equal to u square. So the derivative of f prime u is equal to 2u. The derivative of u prime is equal to cos x. So by du f of u is equal to, by chain rule, we can also write chain rule like this: f of u into u prime, that is 2u. The derivative of f prime u is equal to 2u into u prime. U prime is cos x. So the we know that u is equal to sin x. By putting that value, it will be 2 sin x into cos x, which is not equal to the value of 2x square cos x square. 2x into cos x square not equal to 2x sin x into cos x. Hence, the statement is false. So the next question is the eighth question. Limit of x tends to infinity 1 by 2 raised to x minus 1 is equal to minus 1. We want to check whether this statement is true or false. So the next question is eighth question. Limit x tends to infinity is equal to 1 by 2 raised to x minus 1 is equal to minus 1. We want to check whether this statement is true or false. So So the next question is limit x tends to infinity into 1 by 2 raised to x minus 1 is equal to minus 1. We want to check whether this statement is true or false. For this, we write the equation. The eighth question. Limit x tends to infinity 1 by 2 raised to x minus 1 is equal to minus 1. We want to check whether this statement is true or false. Limit of x tends to infinity 1 by 2 raised to x minus limit x tends to infinity of minus 1 minus limit to x tends to infinity of 1 is equal to minus 1. So the equation will become 1 by 2 raised to infinity minus 1 is equal to minus 1. 1 by 2 raised to infinity will be equal to 1 by 0 minus 1 is equal to 1. So 1 by 0 will be equal to 1 by 2 raised to infinity will be equal to 0. So 0 minus 1 is equal to minus 1. Hence the statement is true. Statement is true. The next question is ninth question. D by dx of integral of 1 to x raised to 4 sec t dt is equal to 4x square sec into x raised to 4. The equation is and d by dx of integral 1 into x raised to 4 sec t dt is equal to 4x square sec x raised to 4. Let me check this. Into x raised to 4. We want to check whether this statement is true or false. For that, the formula for this is d by dx of g1 next to g2x into ft dt is equal to f of g2x into derivative of g2x minus f of g1 next into derivative of g1 next. So the equation will become here f of g2x is equal to sec into x cube, x raised to 4. It's not x cube, x raised to 4. Sec into x raised to 4 into derivative of g2x is equal to derivative of x raised to 4, that is 4x cube, minus f of g1, that is sec into 1, sec into 1 into derivative of g1 next, that is derivative of 1 is equal to 0. So the whole term will become 0. So the final answer will be final answer will be 4x cube into c into x raised to 4. Hence the statement is false, because here it is given 4x square, but the final answer is 4x cube. So the statement is false. Statement is false. The next question is, the function f defined by f of x is equal to 1 by 1 plus x square is integrable on every finite subinterval in R. We want to check whether this statement is true or false. This statement is true because of three conditions. 10th question. F of x is equal to 1 by 1 plus x square is integrable on every finite subinterval of R is true because of three conditions. First condition, denominator is not 0. Denominator will not be 0 and always will be greater than 1, because a square will be always positive. The second condition is both numerator and the denominators are continuous function or polynomial, continuous polynomial. Both numerator and denominator are continuous polynomials. The third condition for these functions to be integrable or Riemann integrable is because the quotient of two continuous functions whose denominators is not 0 will be always continuous. The quotient of two continuous function or polynomial. The quotient of two continuous functions or polynomial whose denominator is not 0 will be always continuous. Hence the function is continuous on the interval of r. So the function f of s is equal to 1 by 1 plus x square is integrable on every finite interval of r. So hence the statement is true. True. So by far we have covered the A part of the BMTC 131 calculus. So we will continue the section B on next video. Thank you.